Now I'd like to introduce our monitor, Mr. Sean Lyman.
Thank you. Welcome everybody for coming. I'm really excited about this panel, especially for those who heard General Holmes speak this morning. He talked a lot about sustainment, acquisition up front, and what we're doing to make our aircraft more sustainable and life cycle, and everything a logistician wants to hear. That's what we hear the warfighter talking about. And I want to say that was not an anomaly. You'll find from this panel we have up here, the focus on sustaining our weapon systems is extremely important to the Air Force and our industry partners. And we're very fortunate here, and as I'll introduce our panel, you'll find we have a great mix of experience running our industrial complex, representing the warfighter, as well as our industry partners to help us better delve into some of these topics. So with that, let me introduce the panel real quick. We have Brigadier General Chris Hill. He is the commander of Oklahoma City Air Logistics Complex. That's where we do all the heavy maintenance and overhaul for our bomber fleet, our tankers. The engines are overhauled out of Oklahoma City, and he also has that experience, as well as the experience as a warfighter working as the director of logistics for our Pacific forces in PACAF, which was a hardship because that was based at Pearl Harbor, so I think that's tough for him to leave there and go to Oklahoma. We also have with us Brigadier General Steve Blameyer. Once again, great background. If you hear anybody in the Air Force talk about condition-based maintenance or CDM, rarely do you hear him talk about it without talking about the C5, and General Blameyer is one of the biggest champions in the Air Force to bring on that vision looking forward and bring it to reality, so we're very fortunate to have him here with us. General Blameyer currently is the Director of Logistics at AFMC, but he also has worked as a complex commander at Ogden. So once again, he has that perspective as a warfighter as well as a sustainer and understands the complexity in both sides of the area. We have Mr. Dennis D'Angelo with us. He is Mr. Supply for the Air Force. He runs the supply chain for us. Once again, perfect person to have on a supply chain panel. We're very fortunate to have him come up and join us today. We have Ms. Sarah Keller with us. She is the Deputy Director for Logistics for Air Force Material Command here at Wright-Patterson Air Force Base, where she has the responsibility for all the policy and everything we do in the Air Force community. So very fortunate to have her here with us. Once again, she has a history in AMC and ACC, working with the warfighter. Very unique perspective. We have Mr. Jack Earhart from Delta MRO Services, Delta Tech Ops, where he oversees oversees all the aircraft. Bottom line is, anybody that flew in on Delta and made it safe today, thank Jack. That is the man who got you here safely. But he oversees all the operations there. Very interesting. I think you'll hear the Air Force often refers to Delta and Delta Tech Ops as a benchmark for what we'd like to be able to accomplish. So for him to be able to take some time out of his day to spend it with us, we greatly appreciate it, sir. Also with us, we have Mr. Mike Much from Collins Aerospace, where he is the Vice President of Supply Chain for Mission Systems, has a strong background in running the supply chain in industry, brings that unique perspective to us to share his experience with us. And finally, we have with us Mr. Chris Davis from DLA Aviation, where he also is running the supply chain out there, and he also does a lot of the work with the acquisition of parts for us for over 2,000 weapon systems and 1.2 million stock numbers. So you can see from this panel, we have a great deal of experience and background, so pretty excited to have them take their time and come with us. So what I'd like to do today is I'll tee it up with a question for the panel. We'll have a few panel members address it, then we'll let them expand on it. But what we'd really like to be able to do is offer the floor up to the audience as much as possible. So if there's anything you want to ask, we will have microphones coming out. Raise your hand, and we'll defer to any questions from the floor before I go on with canned questions, because the entire purpose of the event is for you to be able to have access to this leadership and their knowledge. So with that, I'll start the first question. I'm going to start with Mr. D'Angelo. And sir, how can the government and industry partner to lower sustainment costs while maintaining a focus on readiness?
Thanks, Sean. I always like to be the first guy out of the chute, but I appreciate it. There's a couple ways that we've done this. Thank you.
Sir, they were having trouble hearing you in the back.
Can you hear me now?
Is everybody got
Good?
it?
All right, how's about this? I'm just going to use my military voice and see if you hear me. All right, there's a couple things that we can do. That worked. So anyway,
got you downstairs too.
So there's a couple of things I think we can do. Number one, we've been working on performance-based logistics contracts, and we've been looking at those contracts to help work and to improve the performance both from the military side as well as the customer side, or rather the provider side, the industry side. They're more readiness focused. We did that by design. And then what we've been able to do is we've been looking at the performance piece on that, and actually that's worked out very well. And we think it's worked out both well for the provider, for the OEM, or for the industry, the partner that we're working with, and it helps us actually have a better focus because we have a common metric. But I'm going to tell you basically that that's worked very well. We've also changed what we've done inside of our own organization by kind of reorganizing. We're kind of a commodity-based organization. We always look at commodities because commodities cut across a multitude of weapon systems. One of the issues that we had when we went into the contracts is we keep talking about commodities, but we didn't know how they really related to a contract that would focus on the weapon system. So we've actually stood up these weapon system supply owners, which are basically my group commanders, the guys who work at that level. And what they're doing is they're being more or less the liaisons, and they will convert basically the need for readiness into the commodity requirement that we have that we reflect back in the PBL. We hadn't done a very good job on that before, and we think we've got a better idea of what that requirement is through the use of the WISCOs so that we can actually provide a better input for what we want when we do that contracting. But here's a couple other things, and these are going to be broad terms. I talk to a couple every time we have somebody come into the office and discuss things. I don't let them leave until I ask them about what they don't like about how we operate as a supply chain, as an Air Force, and how we do the contracts. And a couple things that they came up with is, the constantly varying requirement. We order 50 parts from you for a year, and then suddenly we'll tell you about 3 weeks later after we've set the contract with you that we need 50,000 of them. Okay? And I know I got a couple rolling eyes, but you know what I'm talking about. All right, and then we come back and we push you to go ahead and move in that direction, and then suddenly what we do is we found another alternate source and we reduce the requirement after you've ramped up in that one. So we're a little bit out of the sine wave. I force you into a sine wave, and then I'm out of the sine wave by being on the backside of it when you're on the rise. So one of the things what we're trying to do through the PBL contracts and through our WISCOs is to get a better understanding of, you have a better understanding of what our need is, and then we have a better understanding of what your proposition is to meet that need and the constraints that you have. And I think I know a lot of those constraints. I know how difficult sometimes it is to find the raw materials. Sometimes it's a cold start that we have. We're also working to determine how we can be better at forecasting and being more accurate at the forecast. And we think that later on you're going to talk a little bit about in artificial intelligence, the different things we do in CBM Plus to give us a better idea of what the things are going to go bad before they ever go bad, then how we would actually act to put them back into the supply chain should we need to. That's not exactly what CBM Plus does, but it will help in that area. So we would have better idea of what that forecast is and then live to that forecast. And then, like I said before, is that we'd have to look at how we come to an agreement through the PBLs. We've done this in performance-based metrics that we both agree to, and then stick to those metrics. And then, as we've talked, because it's the name of this, in partnership and how we would do things in partnership, we both have to work in a partnership. There's something that I give, I take, you take. But one of those things is watching each other's sub-tier suppliers. We've had issues in the past where sub-tier suppliers did not perform to the extent that they should have, and because it was kind of fire and forget, we thought the sub-tier would actually come up with the answer. We ended up not having the part produced. So I think having an open kimono where we can talk and go into depth to see if there's any problems, and then allowing us to work with you as contractors to solve the issues that you might have as we try to bring supplies into the system would be valuable. So I think our PBLs gives us an opportunity to do what? To build trust in between the two of us, to have a better understanding of how we work together, and then to work together as a partnership to make the eventual goal, which is to bring readiness to the warfighter. And I think through PBLs, a better understanding, we'll have an opportunity to do that in the future. Thank you.
Thank you. Mr. Mudge, would you like to expand on that from your perspective?
Sure, thank you. So I come at it from a little different perspective, and that's the perspective of technology. So one of the areas that drives, from my experience, drives the most cost in sustainment is the expiration of technology. These units are serviced for many, many years, and so the inability to inject continual improvement in technology and the microelectronics particularly drives a substantial amount of cost. So to build on some of what the Dennis said it's when we will order 50, we won't build for another 5 years, and then we'll order 50 more. During that cycle time, we've lost all the expertise to build that, and we probably can't get the parts anymore. Microelectronic life cycles are about 6 months, where we field weapon systems or capabilities for 30, 40, 50 years. And so one of the challenges that we run into is how fast can we regenerate the technology, how fast can we get approvals for new technology to insert in old aircraft in existing platforms or in existing capabilities. And these are at the component level primarily. So if you look at, these are multi-layer ceramic capacitors are a big issue for those of you who are aware of that issue in the industry today. Everything's getting smaller. The electronics that were designed even 10 years ago, we can't get. So when we are asked to go out and contract or asked to build or rebuild a box, as an example, we have a very difficult time acquiring those parts. Or we have to sit on those parts for 10 or 15 or 20 years, and there's a substantial cost and in some cases a life cycle limitation to those parts. So that would be an area for improvement from my perspective, is how do we increase the speed in which we can redesign components or boards or microelectronics in most of our systems that we field today. And that would give us a competitive advantage to both sustainment, cost reduction, and being able to field units when they fail.
I'm gonna jump back on that one for a second. I grab Sean. You're spot on, because I think what we heard today from General Holmes was the fact that we need to be able to operational test and developmental test and bring things to bear faster. In many cases, with the design of, let's say, new electrical systems or new components that would be part of circuit technology, we can do things with a chip we could do with a bunch of resistors and transistors in the past. We've been stuck with a world that says we have to maintain form, fit, and function, which means, it really should look the same and act the same. I think there's really room for us, especially in the world that you work in, to actually modernize and do this modernization for sustainment, but also be able to put it through a test cycle that would be significantly reduced in the ability to bring that new technology. And that way, you're not trying to redesign old technology, which will probably fail because we don't do transistors very well anymore, but you can modernize for the new sustainment. Over to you.
Yeah, so I would also add the other risk to not doing that is as components age their life cycle so that we stop producing. Most of those components now have been offshored. So they're being made in China, in Malaysia somewhere, Japan if we're fortunate enough, and the cost of those components, or we have to source domestic components for source control for obvious reasons. You go looking for old components, you go out in the market looking for trouble. And so counterfeit policies are extremely important for us to get after. We will not accept any parts from China that we use in a DoD environment, and oftentimes they're the only ones that have it, and you don't know if those parts are real parts or good parts or if they're counterfeit parts. And the sophistication of the counterfeiting that's going on today requires a very sophisticated laboratory to be able to determine that that is actually a counterfeit part. So I'd add that piece as well.
General Hill, did you have some comments on that?
Yeah, I do, Sean, and I appreciate the opportunity to pile in. I come at this from a third facet, I guess. And if you'd asked me 54 weeks ago when I took my current job, if I thought that I would spend a propensity of my time focused on the supply chain, I would have challenged that assumption. And what I've learned in this period of time is that a large portion of my attention and focus is on material supportability. And so much so that we actually conducted an enterprise value stream map on one particular type model series of an engine that we repair. And I learned that I'm part of your frustration, quite frankly. And that frustration is really driven by a lack or a shortfall, I would say, in our ability in the factory to send a demand signal to Denny's team. And that demand signal would indicate some sort of periodic demand history adjustment. And I will say that we do have a good process in place and a firm process in place with DLA, but we certainly are in an opportunity or a posture to improve our ability to support Denny in this enterprise and what I like to call reciprocating supporting relationships. we can do a better job.
Just because he's at that end doesn't mean I don't love him. We're inextricably linked on this thing, so thanks, Chris. So,
He did ask to sit on the opposite side. So. Anybody else on the panel comments, sir?
Yeah, I just wanted to add, I remember the frustration that Chris refers to, and I recall doing some interest-round value stream analysis on the supply chain problems that we had, and it was very revealing, and it often did point back to us on the demand side. But as we continue to build further our capacity and our abilities with condition-based maintenance plus and get to that predictive analysis, get to that where you're doing the enhanced reliability center maintenance and you have a high probability of when a part is going to fail in the next 30, 60, 90, 120 days, and you drive that in and you synchronize that with your supply chain, you're now changing towards a demand-driven supply chain where you don't, hopefully you get away from the we need 20, and that's what the contract says, and then you get the call a week later that says, no, we need 500. But you have a much more reliable demand signal on a more regular basis of exactly where you need parts and when you need them. And so that's where we're headed, and hopefully that will help.
Is there anybody else on the panel, sir?
Hey,
Yeah,
Sean.
just from a different aspect of it and from a DLA standpoint, I look at it as when you're trying to talk about cost and readiness, there's what I call myth and reality. The reality part of it is that we're flying very old weapon systems. And sustainment strategies, we're actually paying for the mistakes that we made many years ago by not thinking of the sustainment of those aircraft and how long we're going to be flying them. The myth piece is how do we integrate ourselves into the new systems and the new platforms holistically across the enterprise, and not just DLA and the Air Force, but all services that are going to fly something. How do you build that strategy in the thought process that you could fly the system for 50 to 100 years? B-52 is a great example. The 402 engine on the Harrier. I mean, there's multiple platforms that are out there where I believe that we sat in a meeting a couple weeks ago where we said that in the Air Force's case that we do sustainment really well. And sometimes the Air Force, along with DLA, does sustainment so well that we drive industry into a death spiral from a sustainment platform into obsolescence, where we'll reconfigure something, or we'll find workarounds, or we'll reconstitute parts through reclamation, and we will just kill the supply base. And then we fly those longer than we anticipate, and there's not a way to go out and you find a lot of cold start parts, and there's not rapid manufacturing capability. I mean, our average lead time for an aviation part is over 400 days. In some instances, it's over 600 days. I mean, you can build buildings in that amount of time, and here I am trying to make something the size of this, cup. So just a real quick thought. So integration to the new systems is key, but data sharing is absolutely a must-do. We have to be better amongst the services in the fourth estates, as well as with industry, on what data we're sharing. How do we get after that forecastability that Denny was talking about? Because if we don't have industry, the services, DLA, and any stakeholders as part of that discussion with what predictive analytics we're looking at, what that forecast and the requirement is, then we're just going to shoot ourselves in the foot. So from a DLA standpoint, we are absolutely all in on sharing every piece of data that we can legally, morally, and ethically give you to get after sustainment issues in the future. And I keyed on something, predictive analytics. So we look back to the folks that are building the parts and the OEs to help us with that. So how do we model differently given the problems that we're having with not just reliability on old parts, but how do we look at what's going to fail? So if part A failed and that's an issue, and we know that now the replacement factor is going to change for that, what other parts in that family are more likely to fail tomorrow instead of waiting for it to fail and then being behind that 8 ball?
Ms. Keller, do you have something you want to add to that?
Yeah, so just to kind of touch a little bit on what Denny said about forecasting and certainly on data sharing. As you know, the Air Force has been down this path of modernizing the log IT systems. And one of the things that we're really running through right now, we have a current contract, is obviously to work on our forecasting. And we've been on this journey now for a couple years. I think we're going to come to fruition probably this fall when we're actually going to have something, to start down that path of forecasting. I talked about this in 2000 when I was at the depot, and we always had this idea that wouldn't it be great that if at the depot when you spent your last repair, there's a lot of parts that we only repair 1 or 2 times, that we could send a signal back to, no kidding, the item manager that said, hey, the next time that you pull this part, you know what, you're just going to need to replace it. This goes back to the predictability that we could do if we could just start driving a little bit more data analytics and actually sharing that data across the board, where you have not only the repair centers that are doing it, but also the vendors are getting that kind of information so that we can forecast, no kidding, long term. And then we could do the other things that when is it right to change out the design. It still could be, we could still call it form fit function.
Sure.
But reality would be is if you know the input and the output, right, it might not look the same, but it will do the same function. So we're down that journey. It's just that it's taken us a little bit longer than what we wanted to.
Yes, sir.
Can I just add one more thing? So I think, getting to the heart of this question, which is, how does government industry partner to lower sustainment costs while maintaining focus on readiness? I think the foundation of that evolves around 2 primary things, and that is having common goals, and that the entire enterprise agrees on those common goals, and having a collaboration mindset. And so the common goal should always be in everything that we do, readiness, which for us in the aircraft business is aircraft availability. But the other subservient goal to that is reduce cost. So with everything that you do should be focused, that's the bullseye, aircraft availability and reduce cost. And then the next step gets you to that, which is collaboration. And so Danny talked about setting requirements. That should be collaboration from the start so that you do get it as right as you can. And when you find out later the contract, your industry partner is meeting the contract, but it's not achieving your goal, your aircraft availability and reduced cost, then we need to relook at the contract. But it should always be focused on common goals, and we should all have a collaboration mindset in that, and every senior leader should be mandating collaboration through all their teams.
Okay, before I ask something else, are there any questions from the audience? It's a good opportunity for a good crowd up here. Anybody have anything? If not, then I would like to pull the thread that Mr. Mutch started, where you talk about the supply chain risk management. And that's, to me, is very critical. How are we doing that? And so the question I have is, how do we proactively deal with obsolescence, the counterfeit parts, malware, et cetera, to ensure the safety of our supply chain? If we could, I'd like to start with Mr. Earhart on that, to see where you're doing that from your perspective in industry, and how do you protect that supply chain of yours to make sure you know the lineage of your part and you can ensure that what you're putting on your aircraft is safe for flying.
Thank you. And by the way, all those folks that came into Dayton flew Delta, thank you. Those that didn't, try, you'll like it. A lot of dialogue about supply chain. I think it's a little bit different in the commercial aviation. We have more of a global oversight by all the global carriers. Not that cyber and counterfeit parts aren't an issue. I think even among this panel, we might have a different definition between the OEMs and an airline of what a counterfeit part is. We have the ability as an airline to put a part on our airplane that under our ODA we designate as meeting form, fit, and function. So it may not be produced by a traditional OEM, or we produce it ourselves under adaptive manufacturing or some other means. Our supply chain, a few years ago, we made a distinct change by partnering with our suppliers. We went from over hundreds of suppliers to less than 30. And it's very easy to use the word partner. We all say that. Very few people know how to be a partner, including Delta. But we tried to learn, and so we issued longer term contracts out to our suppliers. we said we will jointly look at investing in technologies, whether it's on our premises or yours. We became much better in discussing out-of-production parts. Maybe they would be offloaded to us to manufacture. The funny question we would ask often is, do you want to keep having us yell at you for a airplane that we're going to fly for 30 years, or do you want us to yell at ourselves? So in many cases, they went ahead and gave us the offload manufacturing to satisfy us and a few other people that were flying the aircraft. We put a scorecard system in place that measures everything from delivery to financial performance to safety to a lot of items. And probably a key element that we did to have open communications, and I listened to your dialogue earlier where we, a lot of self-reflection, we said we were the problem ourselves. We also asked the suppliers to put a scorecard on us. And we think that greatly validated the exchange between us and our suppliers. We do have a major concern right now with industry consolidation. I will flat tell you, and if you're in the audience, it's not a surprise to you, every single engine manufacturer has failed fabulously, both on the OEM manufacturing side and the aftermarket side for over the last 2 years. To fix that, a lot of stuff that we do at Delta, we do much like you do in the Air Force. We do at least 50% of the work in-house to sort of protect ourselves. We believe in self-help, and we try to have a good small list of suppliers that we don't put RFPs out all the time. We invest in them, we pick them for the long haul, and we go down the road. And I think that sort of helps us as we have variable demands over time, that everything is not an RFP. We tend to stay in the game a bit longer. So I hope that helps a bit.
Thank you. General Blameyer, you have any comments on that?
So, so how do we manage supply chain risk, I think is your question, right, Sean? So, so as we know, 80% of our parts demand comes from repair parts, so organic and contract repair. So if we focus on that and realize that a large percentage of those repair parts are coming from a single source, and that creates risk. So what's the solution to that? Well, it would be ideal if we had more than one source. And so seeking and working and collaborating to try to qualify dual source is one avenue we should be pursuing to try to help eliminate some of that risk. Also, encouraging innovation and rewarding that, and then using the data analytics that we are growing into right now to make better decisions on first-time parts or low-demand parts, and getting that right as well, and really pushing the data analytics side of that. And then also, there's a time when we do need, today we might not need the data rights on a part, but we're going to need it someday. So thinking about that as we're building the requirements and fielding systems and working and collaborating and figuring out how to get to yes with our industry partner to know exactly what data rights we're going to need, when we're going to need it, and building in priced options or whatever that is, so that we can both, we can protect the intellectual property, but we can also, have what we need when we need it, so that we don't end up with obsolete parts and not have what we, not have the part on the shelf when we need it. So working hard to get that right.
Great. Anybody else have comments on supply chain on the panel?
I do. So I'm gonna capitalize on the door you just opened and talk about a few things that actually we're doing, and you know of them, but I'll just go ahead and hit them.
That's why I did that.
You are, I know you did. I know you're spot on this piece over here, because we talked about the predictive nature on trying to get ahead of the game, and AI will help us. There's an example that we're trying to do with our propulsion side of the house, where they use, actually I could have started this off with saying that I have enough data, even without sensors, to probably get a good idea of what the next major part's going to break in one of my systems. I am awash in data. The object is I'm not awash in analyst who can go through all the data. So I need to use AI capability to go ahead and crush that data, take that data make it into some type of information, and take my analyst and push it into knowledge, so I would know how to react and what to buy, what to get on the shelf. I can do that. We're trying to do this with Mr. Ralph Garcia over the PEO for propulsion, to do that on a weapon system to get an idea of what we think the next break is. Let's say I take the TF-33, the engine of choice, and I try to look at what the next major issue will be with that. Well, that doesn't mean that anybody out here can produce that part, because it may be that it's a cold start. So what I would do is I would run it through the same data analytics process to determine whether the supply chain could meet that need and where we think the issue might be in the supply chain. That goes that's the same risk issue, because I don't know if the supply chain can meet it. Forget the counterfeit part. Could I find the materials? Could I get somebody spooled up? Could I actually find the place to cast or forge it to make the part? So we've set some contracts out to do that. We've actually started down the IA or the AI path, the artificial intelligence, the machine learning piece, to see how we would do that. And actually we've been pretty successful with a couple of some test pilots that we have done, and we're about to roll into the second part of that and link that up with the test case with the TF-33. That gets me into that area, but then let's say I have a problem, and you hit it right on the nail again here, right? We got to find more contractors that can go out, not sources, I should say, to actually be able to produce the parts. We're seeing that things like castings are a huge issue, because of the number of casting houses that can do high-end castings have been reduced down to just a handful, basically, under PCC. That makes it difficult for us. We're looking to see if we can qualify other smaller vendors to do the type of small work that we might need. And then once we qualify, or actually once we find them, we have to qualify them. That means the process by which we qualify has to be a little bit more rapid than it has in the past, so that we can move forward with meeting the needs that we have. And then finally, you capture the data rights issue. We've been looking at how do we want to do data rights. In the past, sometimes we've said to a sub-tier contractor, go out and get the data rights from the OEM, and that's not worked very well. So we're looking at things like, does the Air Force, should the supply chain go out and do a one-time buy for the type of data rights that I need? I might need only one part, and I could go out and buy it. Can I work collaboratively with the contractor, the OEM, and say, you don't really want to do this anymore, but you could make a little money out of it if I just bought the data rights, and then you and I both help qualify who we think is a sub-tier that will do the work for us. And then we'd run the contract for that sub-tier through the supply chain rather than through the OEM. And then finally, we're also looking at things like licensing. Should we actually, buy a license to do some of the things? I think that's one of the things that General Hill's looking at, some of the things that he might work with a contractor to actually license to build parts that are a high demand for us but low volume for the OEM, so we can keep weapon systems alive. And then I think it was said best, and that is if we can write it into the contract up front and put that into the contract, that's what we'd like to do. But a lot of times we haven't been able to do that, or we're working with existing contracts or existing weapon systems where we don't have the data rights. So those are some of the things that we're looking at right now that we can put in place with our contracting office with Mr. Tony Baumann, probably within the next 6 to 10 months. Over to you.
Yeah, so I just want to add a little bit on the data rights, right? I think every time that we have a data rights discussion, we almost go as an all-in, I want 100% of the data rights or nothing, right? And so we get into this huge philosophical discussion. But reality is that there's a happy medium. And I think we have to explore, and this is kind of where we need industry's help, to explore where the happy medium is. Do we really just need the rights for, if it's going to be an organic repair, the organic cell to go be able to repair it? Is it a technology kind of rights that, quite honestly, this technology is not going to be available for more than 5 years or so? And so, how do we build some of this other kind of mindset going in this data rights? Because at some point, if we're going to have that part for, let's say, 20 years, and the technology is really only available for 5 years, why are we even arguing about it, right? Are we better off upfront, you as the industry, saying, look, in 5 years, you're going to have to go change your technology. We have to kind of change the mindset of how we're going to go buy that second set, right? And we've never talked about this. We've always talked about, we're going to go have this weapon system with this part, and it's going to last forever. And yet, we wonder why we run into MS issues, right? Whereas technology-based, you know, the technology, the manufacturing is changing. We're talking about castings, right? Is castings even the right thing to talk about today when we have additive manufacturing? So we need you guys to come and say, hey, you're going down the wrong path. Maybe it's not a no bid, but you know, that we need a, hey, you could do it better this way, right? So this is really where we need your help.
I'm curious from our industry partners over there, Mr. Munch and Mr. Earhart, what's your perspective on this? So with data rights, because we've moved over to data rights now.
So data rights, I think that's an important concept for us to talk through, because I think at least from our perspective and my experiences, it's the investment in the technology, right? So from a private industry's perspective, selfishly, we want to protect our investment in our technology. And so depending on the data and what you share, who we're sharing it with, we're looking for a return on that investment, obviously. And if the government's supporting that, then obviously they have the technology, they have the data rights. And it's not just as simple as a technology becomes obsolete over a period of time. There's almost always follow-on technologies that are built on the foundations of that IP. So if you give that IP away and then later on you're building something on that, who are you giving that IP to? So again, I think it's a cumbersome subject to discuss, and it really depends on what it is. If it's service data, if it's reliability data, in most cases we're very, very open to partner with that. If you're talking about the technology itself, and we've made the investment in that, we're going to protect that IP.
Hey, I'm going to chime in on a different perspective of this, and I think the government needs to be much more aggressive when it comes to IP, especially when we think about certain circumstances. And for me, when I think about risk in the supply chain, it's a very tactical problem. And so, for example, we did a little homework with Denny's team, and from February of 18 to February of 19, we had 198 sole source no bids, with a purchase requisition value of $57 million over a little more than 16,000 different parts, right? So if you have a sole source contract and no bid on a PR, I think we need to think about this idea of eminent domain for intellectual property. And what I mean by that is at some point, you can't hold on to something you're not willing to produce. And I know that doesn't describe the panoply of opportunity out there, but it is a tactical problem for this guy trying to make sustainment and readiness work in our Air Force.
Mr. Earhart, do you have some comments?
Yeah, so a standard in the commercial sector is that the OEM will support the airplane until there's 5 aircraft left in commercial service. So that's a pretty long time, and that's a pretty big requirement. It is not uncommon for us to pick our airplanes based on what intellectual property we get during the acquisition process. That's the time to ask for it. We get a lot of it. I would say essentially we get what we need. Rockwell Collins, you guys are really tough, but we always manage to work something out. And like was said, if you don't like the answer, there's always a path to the next highest part number, and oftentimes we will do it. But we're not afraid to move the technology in-house when a supplier says, look, you're the last guy using it. If you want it, come and get it. We're also fine to have it restricted for our own use, which is a key, and I think that's something that you're touching on. So the key element is to get it early, Chris, as you're talking about. I think that's the opportunity. And then just to define the boxes that you're going to use it in. We pay royalties for data and rights on it occasionally. We don't like to do it. But again, that goes into what suppliers we pick as we order the airplanes.
So to build on what Chris said, I think if we were to get it, if it were a partnership early, and we really focused on the entire life cycle, which is what this conference is about, I think we'd be very open to that kind of thing in private industry, because then we don't have the risk of we're going to lose the follow-on business, we're going to lose the sustainment business, and we're going to lose control of the supply chain. So if we really want to partner and we want to really look at that, it's not only the acquisition costs, which in my experience seems to be the heavy weight of how we acquire the equipment is based on acquisition, not on sustainment. And I think I'd like to see us balance that, and then how do you connect those two so that the same provider gets that? Now I'm willing to talk about IP, because now we're a partner and I don't have risk to lose that business.
Yeah, I want to say I think that sort of circles back to what we said. We partner with the supply chain. We make a longer-term bet at it. And who knows what the future looks like, but if you've sort of got that as a cornerstone, you can negotiate and find a solution. Airlines are going to be around for a long, long time, and so are the suppliers. So when we just talk about Delta, one of the things that we do is we own stakes in 5 other airlines, so we typically talk not just about Delta, we talk about the entire alliance. So in round numbers, we're talking 5,000 airplanes, not just the 900 airplanes at Delta. That's all the leverage that anyone needs. You're going to have a good conversation.
Yeah, for just another way to look at this is, General Hill brought up the no bids from sole source parts. We probably average, I bet, 600 per month across a big, large variety of consumables and in some instances reparables. But you have to pull the string on that, right? So why are we getting no bids on sole source parts, and we're coming back and asking for a sole source manufacturer to provide a part? The reality is we may have not bought that part from them in 15 or 20 years. We may have broken that part out over time, and now that manufacturing base or the original source can't make it, and then we come back to the original OEM. And I'm not saying that there's not cause there for the OEM to partner with the department to develop or remanufacture that part or to talk about the IP. I think we just have to be understanding of where we are today with some of the weapon systems that we are and where we want to be tomorrow. I really like what Jack said about, when you build and you're buying that support level, that you're supporting it until there's 5 aircraft, having that long-term strategy in the future. But General Hill would tell you that today he's faced with the piece from an IP perspective or a parts perspective of it's one-offs that are killing us. Parts that weren't supposed to break, we were never supposed to, buy again. And now what do we do when we're in an environment where the only approved source to manufacture that part is Collins or Delta or Boeing or Parker or whoever, and I do not own the IP, and now I'm in a bind. And not only are we within a lead time, and it might take 400 or 500 days to find somebody, but I'm arguing about who can make the part or who owns the data rights or how can I do that. From my aspect, we need to have those conversations quickly, and if a company is not willing to make an investment in being able to provide those parts, then we should have the data rights to go back and either organically manufacture or to qualify a new source ourselves.
Great. Could look at the audience again. Any questions from the audience before we?
Come on now.
Yeah,
There we go.
There we go.
It's about time.
Yeah, it's been an hour now. It's time for you to talk. We're gonna steal a microphone and get your microphone, sir.
They just won't hear you in the back.
Thanks. So I just had a comment and a question. So with regards to data rights, and I wanted to talk to Mr. Much's conversation about early partnership, and I think that that's a really insightful comment. That I think a lot of the real problem around primes is that they are really relying on sustainment dollars. They just really are, right? Without having any innovation dollars, right? That's kind of the business model. But if they had a better sense of the total cost of ownership and the return on their investment upfront early, then I think that they would be right at the table, right? And that's what I've heard in my conversations with primes and in the supply chain. So I think that there is maybe one gap out there that it would be interesting to get your feedback on how important this gap is and kind of what it would do from the panel. And that is a real solid lifecycle support plan from the beginning to the end on a platform at the WRA level, even down to the circuit card assembly and even the electronic component, but basically down to the lowest level that you have data rights on. if we had those in place that actually had a total cost of ownership with sustainment strategies and what data rights would be required and when Rockwell or when Collins wants to get out of the business and, you know, kind of how that all works, I think that would be a huge game changer. But this is me on the outside looking in, and I'd be interested in understanding what the panel thinks about that as kind of a strategy, a business strategy to kind of plan our way through this whole legacy sustainment issue. Thank you. I'll take my answer offline.
So I guess I would call this the sins of the 90s, right? So prior to the 90s, I think the government went in and actually bought data rights. We did a lot of these life cycle support. We worked with the OEM. You know, we laid down a pretty good work structure as far as, you know, where the parts were going to be repaired and how they're going to be repaired and what that life cycle was. And then in the 90s, you know, we went out and said, hey, we're going to perform these CLS and we're going to go performance-based and we're not going to really need that. I think now we're going back to, hey, there's a happy medium, right? We don't need to own it all, but we got to get that support structure again. And so we're rebuilding, right, some of that work that we did back in the 80s. It can't be like the 80s. We're not going to be able to afford everything. But I think we have to, this is where we have to partner with industry and says, what's right that the depots probably need to do from a repair standpoint because it's going to last 15 years and beyond. What's right that technology is going to change every 1 to 5 years, and instead of putting down a repair, we really need to rely on the OEM or the vendors to continue to you know, refresh that technology for us. And then there's a middle ground of 5 to 15 years that we got to partner because we're going to go back and forth. So we have to look at the whole life cycle sustainment and how we plan out our whole life cycle of that weapons system differently. It is not, we're going to keep everything for the next 100 years, because we know that if we take that mentality, we're always going to be behind the curve. And we are going to have sole source contracts that are going to be no bid. So this is kind of where all of us need to maybe have a culture change and start driving that. And we have to think about, at some point, where do we do these small investments throughout the life cycle? So it's a repair, an investment, a repair, not repair forever, and then you know you have this huge problem, and then now you have to go find vendors.
Anybody else on the panel want to take a shot at that?
Nathan asks me this question all the time, so I get a chance to answer it again, but it's a good one, though. You said something in your question, or your statement and then your question, on the fact that we have OEMs that are now focused a little bit more on sustainment and not as much on innovation. Did I capture that right? Well, Dr. Roper has been looking right at that. I mean, months ago when he came to visit us, one of the things that he talked about is he'd like to see that model change. He'd like to put more of the innovation back to the OEMs and take more of that sustainment piece, because he wanted to turn weapon systems over faster. And I think Sarah kind of touched a little bit on that, you know, on how we would do that. I just don't know how we would get there, because we've had, since the 90s, we've been more or less on this ride where sustainment was actually handled by the OEM. And then we keep the airplanes for a lot longer. So I know that we are looking at how we can work. In some cases, I think that in the case of data rights and intellectual property, we actually have them and we don't know we have them, because we haven't studied to know what we have. And we could get away with some things. I think in many cases, if we build the part in our own facilities and we're not going to subcontract it out, we already have the rights to do that. You know, it's the things that we can't produce that we're up against the stop against. And I think, like Sarah says, that maybe we have a way that we have to change the process. But I know from our discussions in the past where we are is, how do we get from today so I can get something on Chris Hill's floor so he can make engines, you know, as quickly as he can. And if we're lead time away, the longer we spend waiting to get through the issue of intellectual property and the problems that we have with it. So like I said earlier, that the royalties you've heard from Delta and from Collins, that, yeah, we buy royalties, and I think you're going to see us do some of that stuff to basically accelerate the process and all that. I agree that life cycle sustainment is a true plan, but like Sarah says, some of that stuff we won't be able to afford, so we'll have to take a hard look. And we're working, in many cases where we didn't have that plan, to back ourselves into some type of plan in the future. Thanks for the question. Go ahead.
Actually, just one follow-up on that. Sorry,
We're going to get this guy here next.
Okay, good stuff. Which is something just to bear in mind. I think it goes back to the partnership comment, which is that, it used to be like 70% of the data that a prime uses, they don't have access to. Right? So even if we can get the data, get the primes, and they can't sustain the systems, so how is the Air Force going to sustain the system? So I think this is where that partnership thing really comes in, with predictable total cost and return on investment. If everybody kind of knows what the baseline is, then I think the primes will then have the leverage and the information, then go into the supply chain and basically do exactly the same thing that you want to do with them. So.
I'd like to add on that. We get a lot of requests where the term, we want to learn how to use best commercial practices. But the actual fact is that everything that's FAR 15 has no chance of being best commercial practices. And maybe at FAR 12, I could deal directly with you and not have a middle person. Often the things that we can do at Delta on commercial derivative aircraft, you don't need anyone between us. We could have a really nice contract, and we could probably go a lot faster, and we could definitely go cheaper. So we put those barriers between us for some unknown reason.
Hey, Jack, also talk about your leverage that you have with Part 123. I mean, that's such a different, your organizational construct as an operator and your ability to use a 123 lever really improves your negotiation perspective when we think about our similarities and our differences. And I've spent some time with Jack in the last year, but I think that's an important part to distinguish in this part of the conversation.
Because you're right, it's a 121 operator. So we have hundreds of engineers and a quality program that's been sanctioned by the FAA. So we can build our own parts. We can approve our own parts under our ODA, and that enables us to sort of keep our fleet going. We can take our maintenance customers and do engineering for them and hand them our document that says, we suggest you could do this to a part, and then they give it back to us and say, do that to my parts, and because they're a 121 operator as well. I can't do it for a leasing company or some other entities, but an airline can do that. But Chris, you're right. That gives us the feasibility, and it's all built around our reliability program and our quality systems. It's not on a question, but I want to chime in on something that was earlier, and I noticed the buzzword in a lot of places is predictive, and Dr. Roper and General McMurray were all part of getting a Rapid Procurement Office assignment to Georgia Tech and Delta, and we're working on a project. What I urge you that this project, the short-term answer, what it's going to say is the real answer is a bit upstream in understanding your own reliability program and what drives your reliability. The predictive part is the cherry on top of the sundae. It's the very end. And we've learned that on our journey. It took us 10 years or so. And we're doing a project right now that shows that. But again, getting ahead of the parts, what parts you need, and getting them ordered and working with your OEMs, that's all in your reliability program. And if you just pay attention to your top 10 drivers, you do have 80% of it covered. So anyway.
And so, Jack, just to add on to that, so that's what we're doing. Exactly what we're doing in the Air Force now is we learned from you that the predictive part is only 20%. The reliability is 80%. And so C5 is the only aircraft right now that has those predictive alerts based on the sensors and the algorithms which the engineers have built. But as we roll CBM Plus out onto each of the other platforms, it's all based on the enhanced reliability center maintenance and doing that Weibull analysis and that enhanced analysis to determine by tail number by component what the probability of failure is. And so, yeah, that's where we're headed. We have the data to do it. What we don't have The bottleneck is engineering. We are short engineers across our program offices. Their bandwidth is taken up by many high priorities, and so that's our constraint right now.
Great, that's a good discussion, good question, thank you. Sir, I have another question from the audience.
Yeah, my question is in regards to the latest issues as a national emergency by President Trump regarding the cyber attacks at the second, third, fourth tier level in the communications industry. May impact Collins a little bit. And it's such an emerging issue that who's going to grab it and work with it? And I'm curious how industry's approaching it.
Yeah, what I would add to that is, in no uncertain terms, we are under attack, Collins Aerospace, every single day, every single minute. Our servers are hacked, tried to be hacked 24/7 from all sorts of unknown sources and known sources. The problem's real, it's present, it happens every day. I can tell you we partner very closely with the national security agencies to protect the data, protect your data, protect our data. And we keep that, we don't farm that data out. That data stays in resident servers. You know, a lot of this phenomenon with the cloud's very vulnerable. Even in the case of some of the .gov cloud applications, they've been compromised in some cases. So we do keep that on a different network. It is a separate private network. It is not available to the internet. Those are things, it's interesting how technology, as advanced as we get, we're now actually installing networks that are similar to what we had in the 80s, where they're not connected. So common sense, right? So if you're not connected to anything, you can't hack into it. Now it's a physical security issue, which is also a very clear and present situation as well.
Short follow-up.
Sure.
What about the second and third tier down?
Yeah. Very, very challenging problem for us. One of the ways that we address that is documentation control. So we have, in fact, drawings, as an example, are controlled on our servers with their access. In many cases, depending on the program, they actually have to come into one of our facilities to access those drawings and look at those drawings because of the sensitivity nature. We don't transmit a lot of that. Depends on the program and the situation, but that's how we manage a lot of the second, third, and fourth tier suppliers.
So I kind of want to flip this upside down for a second and ask you your thoughts on this. In aviation, we have a really strict kind of mindset on quality of parts and parts pedigree and a lot. Have we looked at it, and in particular I'd be interested in Delta, but anyone looked at it in the idea of how could we build, I mean, from a supply chain standpoint, we want a robust supply chain. How could we build and design in a way to allow us to use parts from many, many different sources and be much more immune to variability and quality in the parts that we get? I mean, if you think about that, we're going to have to ask that question with respect to additive, because the additive systems are coming along, but there's still, we're going to want to use those long before we get complete control at the molecular level of the variability of that process. Is there have we looked at design to give you an ability to use just a broader part set and maybe leverage automobiles? I mean, Elon Musk looked at the automotive industry toward rocket parts. You know, have we looked at that?
Yeah, that's a great point. I don't have an answer to that. I know that under a 121 we are doing printing. We start off with interior parts. We are doing some engine parts now. As General Hill said, it's our 121 allows us to do it. We can't sell it to others, but it's an interesting. We can't bring in aircraft automotive parts into aviation right now. We just know that. But to your point, can the engineers develop strong enough that it may only cost a nickel more to be able to go across both industries? And I think that's sort of what you're saying. I don't think we've tackled that.
Hey, sir, so you know, again, I think it's because we have the mentality that this part needs to last forever. And if we're really going to use things like additive manufacturing, we have to think about things like, well, was it hard to manufacture in the first place with the legacy manufacturing techniques? I can think of, you know, brazing. You know, anytime that you braze anything, it's hard to manufacture. And so you almost have to compare that new manufacturing technique to the other and then go, okay, even if it only lasted one time, one cycle, instead of lasting forever and it being repairable, are we going to be able, first of all, to meet the mission requirements, and second of all, to be able to meet that cycle? Maybe up front, we go to a lower cycle. Maybe it's not a 5-year part, but a 3-year part. We've got to start driving that kind of mindset, because we're stuck in this piece in the Air Force of everything has to last forever.
I also want to not tack, but talk to that. Because I'm glad you asked it. You're doing a great job. You provoked it. General, I'm in your camp because I think that we should be able to use a multitude of other parts to get us there. Here's the one thing that I mentioned earlier, I think before you got here, is the fact that we have situations where if we're looking at form, fit, and function for an electrical component, we may be able to find those electrical components that exist anywhere in the world right now that can actually replace a circuit board that we have. But then we have to go through a full, you know, SAR package, a full OT&E. We have to go through a developmental test, and then we have to go through an ops test. If we can work, which we should be doing, and I know your staff is doing it, we're looking at how can we shrink that timeline? How can we say that part has 1,000 hours, or 100 million hours in a car, and it would have no difference if you stuck it in the airplane, and actually would probably work the same. And then we can shorten the amount of developmental tests and operational tests that we have to do, because we're basing it on a performance factor that it's had before. I think we need to move that way. I think you're exactly right. There'll be some components. You know, I don't want to put anybody in an area where it's not safe, or in the middle of combat and the system doesn't work. But I think what we can do is we can prove that the system will work, and the replacement will be, as Sarah says, for sustainment. We'll replace those parts so in a more, you know, a faster cycle than we have as technology is advanced. But we should be able to use existing technology or leverage existing technology that's been proven someplace else to shorten our time for developmental tests and operational tests. Thoughts? I only get to talk to you like this at this event, so.
I think it's great. I was just trying to drive at what you really want is a robust supply
system,
chain.
right.
If you can spread the number of suppliers, if you can find a way to design so you can use lots of suppliers and not be so sensitive to, you know, it being perfectly qualified, it's there. I mean, you can think of that in the additive area of if you design with triple or quadruple redundancy, you know, then the fact that you have a little variability in the buildup of those parts might be okay. You know,
that becomes the discussion between your engineers and my engineers as we start to look at.
Yeah, and then the engineers, they just go. As an engineer, we just go right back to what we know. You know, that's where we've been. Okay, it's like we've got a proven process. Been working it since 1948.
So sir, I think you're driving your point home that it takes senior leaders to drive this and to expect it. I was part of a team 7 years ago at the Oklahoma City ALC where we figured out how to change the paradigm of engine blades and got engineers to accept refurbished engine blades. And that was huge to get them to go. I remember on day one, they were like, no, this is never going to happen. And then, cannot be done. And then 3 months later, it was, you know, this might work. And then we did it. And then the next step was getting contracting to allow it, and they figured it out too. So it's just changing the paradigm and getting people to think differently. But senior leaders have to drive it.
And then having the data analytics to say, when I made that decision, or when that decision was made, that you can actually go back and get the feedback that says it's still working, right? That's that do loop that you have to have with the data analytics so that you can get that trust and confidence building up.
Chris, I want to add on to address a couple of things that General said. So TCAS, TAWS, Those types of systems, if you drive your car, all of that's from the aerospace industry. So we think about the automotive manufacturers being fairly advanced, and they are when it comes to volume and doing a lot of things, the same thing a lot of times well. But when it comes to pushing the edge of technology, I would say that most of their technology now, in fact, they're causing a lot of our part shortage crises right now because they're putting TCAS and TOS systems in your car, in your truck, right? So you don't hit something, or you know it's coming, or it drives itself. That's all aerospace technology. Those are all our sensors that you guys have on your aircraft. So that's one point. The other thing too, and I do think the general is a good point. It depends on the technology and what technology you're trying to repeat or spread across the supply base. When you're thinking about mechanical technologies, I think that's an excellent strategy. When you're talking about electronic technologies, it's extremely difficult because of the connected aircraft. Everything today is connected, be it the weapon systems, the environmental systems, the pilot itself, the aircraft, all of that is connected. To have multiple manufacturers make different components there makes it very, very difficult if you're not the system architect. And this gentleman has to repair it. It becomes extremely complex.
Okay, I think we have a few minutes left. We have one more question in the audience. I'd like to get to that. If the panel can bear with us for one more question.
It's for Ms. Keller. So when you all were discussing that it's 80% reliability, 20% predictive, I saw Ms. Keller shaking her head very definitively up and down, but you also had discussed at the beginning of this session about the system that you're hoping to have out at the end of the summer, and then you just a minute ago were talking about data analytics. Could you describe a little bit more about what you all are doing?
Yeah, so you know, all of our aircraft are legacy, so we have lots and lots of information, right, on maintenance information systems, supply. I mean, you know, we have all this data, but it's not all together. So a couple of things. We have what we call Blade, that's really just putting all of our information together at Ogden, that is now going to have this curated data that we can start pulling from and actually start doing some data analytics. That's being done organically in concert with AFSC. It's not necessarily a cloud, right? It's still on-prem, but we're getting down that piece. We worry about when we put all this information together, that we start changing the level of security, because you can certainly start driving where and when, right, we're changing out these parts on there. So while we want to do data analytics, we also want to make sure that we're secure. On the second part, you know, we have a contract called Escape. And so this is the forecasting that we've always talked about for the item managers to be able to forecast, not just using data from D200 that does 8 quarters, you know, prior, but a longer cycle. If we go look at aircraft, we run on a 5 to 7 year cycle for PDM. For engines, we probably run anywhere from 4 to 8 years on cycles on switching things out. So we know that we have to collect more data, but we have to actually analyze it a lot more. And going back to, you know, Denny's point, it's not that we don't have the data, it's that we can't get to the data because we're doing it manually. So we're trying to strive to get, you know, things like Escape, the contract for Escape, to do that forecasting, but also doing our own data lake and putting all of the data so that we can actually start doing a little bit more analytics. And it's something that we haven't done. While there's pockets, I think engines, you know, is very robust in that. We have pockets of excellence, but we don't necessarily have it across the board. Again, things that we have lost since the 90s. We used to have 1515s, you know, back in the 80s, but we certainly cannot do it manually, right? I mean, we have to have the machine learning to do it. We have to have all the data in the right place. Did that answer your question?
Okay, I think that kind of takes up the time where we are. I think the next step for everybody's lunch. I'd really like to thank the panel for coming up, but this is excellent discussion.